PreAP, PreCalculus. We're looking at homework 11.3. These are transformations of trig functions. Concerning the graph on the right, which trig function is this? Well, the trig function that has the beginning, middle, and end of the period on the midline and a quarter of the way through above and a quarter of the way through, 3/4 of the way through below, that is sine. What's the amplitude? Well, the amplitude is the absolute value of this lead coefficient. So it's the absolute value of 2, which of course is 2. What's the period? If you take function f and do all these transformations to it, what's the period going to be? Well, the period for sine is 2 pi. So if we take and we dilate this horizontally by 2, it's going to stretch it horizontally. So the period is going to be twice as big as 2 pi is 4 pi. Question 2, which trig function is pictured to the right here? Well, sine of 0 is 0, so the reciprocal of 0 is undefined. That tells me that this is going to be cosecant. So f of theta is cosecant of theta. What's the range of this function? Well, for the parent graph, the range goes from -infinity to -1, and then from 1 to infinity. The 3 and the -2 is going to affect the range. So the midline is going to be at -2, and then it's going to, instead of going up and down 1 from that, it's going to go up 3 and down 3 from that. So I like to just say y equals -2. If you go up 3, you're going to be at 1. If you go down 3, you're going to be at -5. So the graph consists of a bunch of parabolas, similar to parabolas. And it starts at -infinity, goes up to -5, and then goes from 1 to infinity. So the range is -infinity to -5 inclusive, and then from 1 to infinity. Now you can see here the distance from -5 to 1 is 6, and halfway between -5 and 1 is -2, so that all checks out. What's the period for this function? Well, this 2 affects the period. The parent graph here has a period of 2 pi. This 2 is a dilation horizontally by a half, so if you cut 2 pi in half, you're going to get a period of 1 pi. Number 3, which function is this? Well, this is tangent or cotangent. Tangent's the one that starts and ends the period on the midline, so this one is tangent. What's the period? Well, the period for the parent graph for tangent is pi. This 1/3 that you're multiplying by inside the function dilates the graph horizontally by 3. So the period is pi times 3, which is 3 pi. Write a function h of x. There's a little extra here, probably don't need. Write a function h of theta that would transform f of theta into its reciprocal trig function. Well, let's see. To do that, let me show you what would need to happen. First of all, we would want to translate this to the right so that the vertical asymptotes lined up at 0 and pi. You could also translate it to the left so that happens as well. So this translation that I'm going to refer to here, theta, could go left or right. I'm going to go right by pi over 2. So, well, I'm not going to use tangent. This says function f, so I'll do function f. Now, if we did what I just suggested, that's going to put it over here like this. Now, let me remind you of what cotangent looks like. this is 0 and this is pi, cotangent looks like this. So from what I'm showing you up here, this gets things lined up as far as the asymptotes, but the curve is wrong. So the curve that I have right now for tangent is below the midline, then goes above, but cotangent's above, then goes below. So how can I fix that? Well, if I do a vertical reflection, that would fix that. So h of theta equals negative f times the difference of theta and pi over 2. That would transform f of theta onto its reciprocal trig function, cotangent of theta. 4 through 7, identify the range of each of the following functions. Parent graph for cosine has a range from -1 to 1. This -4 makes the midline at -4. This 2 means that we're going to go up 2 and down 2 from this -4. Up 2 is -2, down 2 is -6. So the range for this is going to go from -6 to -2. For secant, secant has a graph that looks like this. It's a bunch of parabolic-like shapes with vertical asymptotes between, and normally it goes from -infinity to -1, then 1 to infinity. This plus 4 takes the whole graph and translates it up 4. So if your midline is at y equals 4, and you go up 1 from that, you're at 5, and down 1 from that, you're going to be at 3. So the range is going to go from -infinity to 3 inclusive, and then from 5 to infinity. Tangent, none of this is going to affect the range because the range for tangent goes from -infinity to infinity, or all real numbers. Cosecant, like secant, consists of a bunch of vertical asymptotes and then shapes that appear to be like parabolas. And this -3 means the midline is at -3. And then this 2 means that we're going to go up from that 2 and down from that 2. So that means that the range for this is going to go from -infinity to -5 inclusive, and then from -1 to infinity. -1 included, infinity not. Pictured below is the graph of the trig function f of theta. Use the graph to determine if the following statements are true or if they are false. 8, if it's false, so it says give an explanation for your reasoning, whether it's true or not. 8, the graph of the function f of theta is cotangent of theta. That is false. This is a graph of tangent of theta. So I'm going to say false. F of theta is equal to tangent of theta. That's a good enough explanation, I think. 9, the period of the function g of x, which is 2 times f of 2 theta, is 2 pi. That is also false. The period for this is going to be pi times a half, which is pi over 2. So an explanation for that is g of theta has a horizontal dilation of 1/2. If it's inside the function, it affects it horizontally, and it's typically the number does the opposite of what you would think. Times 2 really means dilation of 1/2. 10, the domain of the function h of x, which is defined as this graph here, translated to the left pi over 2, is -infinity to infinity, except for x equals k pi, where k is any integer. Well, let's see. If we take the vertical asymptotes that are currently here, let's do that real quick. Just tracing over them. if I translate them to the left pi over 2, then yes, that matches up perfectly. So currently, like before I did that transformation, f of theta has vertical asymptotes at pi over 2 plus k times pi, where k is any integer. If I translate this left 2, which is what this is saying, then that's going to change this to be what it's supposed to be. So first of all, this is true. K of theta has vertical asymptotes at pi over 2 plus k pi, where k is an integer. H of x translates vertical asymptotes left pi over 2. Good enough. 11. This function that you see up here as x approaches negative 11 pi over 2, then f of theta approaches negative infinity. So first of all, is there a vertical asymptote negative 11 pi over 2? Well, let's see. Well, I'll tell you what, if we just take this concept here, we said, well, this can't be right. Let me tell you why this can't be right. This is a two-sided limit. If you're approaching negative 11 pi over 2 from the left and the right, in no place here, if you approach a vertical asymptote from the left and the right, is it going to both negative infinity. So this is false. First of all, let's see if negative 11 pi over 2 would be a vertical asymptote, and it would, because of what we said there. Let's see. So this ties into the limit existence theorem, which we may have had in PreCalculus. I know we have it in the first section of calculus that you're going to learn soon. Let's find the limit of f of theta as x approaches negative 11 pi over 2 from the left. And let's find the limit of f of theta as x approaches negative 11 pi over 2 from the right. Since we know there's a vertical asymptote at every pi over 2 separated by pi, at some place there's going to be a vertical asymptote at negative 11 pi over 2. If you approach from the left, it's going to be going to infinity. If you approach from the right, it's going to be going to negative infinity. The limit of f of theta as x approaches negative 11 pi over 2 from the left is not equal to the limit of f of theta as x approaches negative 11 pi over 2 from the right. If this doesn't make 100% sense to you, I apologize, but it will when we do the first chapter of calculus, which is going to happen sooner than you think. That concludes the homework.